Right, so the poll yesterday, 13 people responded.
I'm going to join that right now.
The poll, yeah, you can join. There's the access code.
I said yes.
The poll yesterday was, if I drive twice as fast as you, will it take me twice as far to stop? And I had 4 people say yes, and I had 9 people say no.
No. Yes.
Let's look at the graph. Okay? Before I do that, what was the magic number? 3.6. If you're going from meters per second to kilometers per hour, oops.
So it's even worse then.
Meters per second to kilometers per hour is times by 3.6. What if you're going the other way? If you're going kilometers per hour to meters per second, it's divide by 3.6. How many people think that would be a good idea to have that on their cheat sheet for this unit's test? Everyone's hand goes in the air. How many people in my teaching career have messed that up, gone the wrong way? Probably around 20%. Don't let you be one of those 20%. Get it right. Get it on your cheat sheet. You can't make the mistake. Do it right. Okay, here's the way I remember it. Meters and seconds are small numbers. Kilometers and hours are big numbers, so you have to make that meter per second number bigger by multiplying. Right? And if you want to make it smaller, going from kilometers and hours to meters per second, you have to divide by 3.6. What does independent and dependent variable mean? Anyone remember from yesterday?
Independent is the one that you change.
Yep.
Dependent variables are the one that change.
Changes because of it, right? Excellent. And on a graph,
What's the access code?
I'll show it to you. On the graph, the independent is on the x and the dependent is on the y. And I would suggest you make little notes in your margin. There are, on occasion, times where I'll ask you to flip the independent and dependent, and that's okay. The reason we do that is to make the slope make sense. And that phrase, slope makes sense, will make more sense to you when I'm done today. Okay, so let's go back and answer our question. If we can look at either the graph, or we can look at, I'm just going to move this out of the way here. We can look at the graph, or we can look at the data itself. So if I'm going twice as fast, find me 2 numbers that are like two numbers, one that is twice as much as the other one on that chart here. 10 and 20. 10 and 20. So 10, a total distance of 16 and a half. 20, a total distance of 51. Is it twice as far? No, it is not. In fact, it should be. How much bigger is 51.3 than 16.5? How much is it? About 3? It should be almost 4. Take your calculator or your phone or whatever you got there and take 51.3 and divide by 16.5. And I'm guessing you're going to get like about 3.8 or so. You will need a calculator for here, and you will need a scientific one, and I would really rather it not be a phone. How much? 3.1, that's all? Okay. It should really be ideally 4. Right? It should be 4. Now, how come it's not exactly 4? Well, because this is a measurement, and all measurements are somewhat inaccurate. Okay, so that's about as far as we got yesterday, right? Okay, so let's actually talk about actually plotting graphs. These steps will help you plot graphs from data tables, and I just realized that I'm going to need graph paper. Morgan, can you look and see if there's graph paper on that top shelf back there? I really hope the answer is yes. Is there like a stack of graph paper? How much? How many? Not enough for the class though, right? Okay, I'll have to go run some up. So these steps will help you plot graphs from data tables. That's really small. Let's make that a bit bigger. You guys should probably just follow along on yours. Identify the independent and dependent variables. Decide which one goes on the x, which one goes on the y. Independent is plotted on the horizontal or x. Dependent variable is plotted on the vertical or the y. In our example, speed is plotted on the x and distance is plotted on the y. Determine the range of the independent variable to be plotted. What does the word range mean? It's not the place where you cook dinner. Not that one either, Lucas. That's a different range. How do you know what range is in math class?
The,
From one extreme to the other?
On the y, I think, right? Domain and range, right? So range here, we're talking about one extreme to the other. So what's the smallest x variable? What's the biggest x variable, right? That's the range. In the example, data are given for speeds between 10 and 30, so a convenient range for the x-axis might be 0 to 30. How come, even though I start at 10, how come I start my graph at, oh, I started at 10, that was a bad idea. How come you should start your graph at 0? Should you?
yes.
Do you have to?
You should have a common point for that connecting.
If you can make 0 work, it's always good to have it in there. Try to make 0 work. Unless your first x is like 8 billion, put 0 in there. Decide if the origin is a valid data point. What does that mean? The origin is at 0, 0. Valid data point. If one variable is 0, should the other one be 0? A lot of the time it will be. In this case, would it be? Would that be true? If the speed was 0, the speed is 0, what would be my stopping distance? 0. If you're not going anywhere, what's your stopping distance?
You're not going anywhere.
You're not going anywhere. It's 0. 0, 0 is a valid data point, right? If it is, put it on the graph. Spread out the data as much as possible. Don't scrunch it into one little corner so that it's basically just a blob of blue ink. Not very useful. Spread it out so we can see it. Let each space on the graph paper stand for a convenient unit. Choose 2, 5, or 10 spaces to represent 10 meters per second. If your x goes up by 1s, does your y have to go up by 1s? No. In fact, that happens all the time. Don't worry about that. Number and label a horizontal axis. Repeat steps 2 to 4 for the dependent variable. Plot your data points on the graph. Draw the best straight line or smooth curve that passes through as many data points as possible. This is in italics, and I'm going to put it in bold. That's how important it is. Do not use a series of straight line segments that connect the dots. I'm even going to highlight it and underline it and all that stuff. Do not use a straight line segment that connect the dots. Why not?
The direction isn't really that straight.
When you're looking at the graph, are you looking at specific details? Like, do you want to know exactly what's it going to be between this dot, this dot, this dot, and this dot? Or are you looking for sort of like the overall trend? The overall trend. You're looking for the overall relationship. So you want what we call a line or curve of best fit. Have you guys heard that in math class before? Line of best fit? Maybe you take a ruler and just sort of guess. Okay, that's what we want, is a line or curve of best fit. The graphing calculators, spreadsheets can do that, and you're probably going to get to that hopefully today. Okay, so this was one of the targets for today, was recognizing linear, quadratic, and inverse relationships. The graph figure 2 of reaction distance versus speed is a straight line, this one right here. That is, the dependent variable varies linearly with the independent variable. There is a linear relationship between the two. If there's a linear relationship, the graph is a line, right? If it's a linear relationship, the graph is a line. The relationship of the two variables shown in this graph can be written as the equation y equals mx plus b. How many people have heard of y equals mx plus b before? Good. But what does the m stand for? Slope, which is the ratio of the vertical change to the horizontal change. Or the, like people always tell me, the slope is it's the something over the something. Rise over run, right? How much it goes up over how much it goes sideways. Rise over run. How many people have calculated slope before? Good. That's not what I asked. Vertical change or rise is the difference in the vertical, blah, blah, blah. Here I've calculated the slope. Now, I can see, I look out over the vast landscape of the classroom, and I can already see people are starting to nod off. Are you starting to fall asleep Friday afternoon? 2:37 in the afternoon? Fall asleep? Okay. This next part is important, so wakey. I've calculated the slope of this line. I've gone 18.5, which is this point right about there. I think I pulled it off this chart here. Yeah, no, I haven't pulled it off 18. There it is, 18.5 and 25. Okay. So I pulled 2 points off here. 25, right there, 18.5. I'm using that data point, and I'm using that data point, and I found the slope. Okay, what's the value for my slope? Nate, what's the value for my slope up there? No, it's not 25. 0.74 is my slope. You'll notice there's a letter after that 0.74. What does 0.74s mean? Seconds. 0.74 seconds. How did I get seconds? If you take meters and you divide meters per second, and Mr. Friesen, anybody have Mr. Friesen? Grade 9? Yeah, maybe a few of you. Did you ever use the words dimensional analysis? No.
Word lackadaisical.
Lackadaisical? You know what that means?
Yeah, he called me that.
But did you know what it means?
Yeah.
You looked it up at home?
No, I knew what it means. I was kind of upset.
Yeah? But it's better than calling you lazy, right? Because then everyone else knows what he means. He was sheltering you from calling you lazy. So I've got meters divided by meters per second. And when you cancel them, you get nothing over seconds, which is seconds, by the way. So 0.74 seconds. What does that mean? If it's seconds, it's got to be what? What do we measure in seconds? Time. It's got to be a time. So what is 0.74 seconds? What does it mean in this case? Well, it has a meaning. Okay, and I'm going to get to that in a second. Notice that the units have been kept with the variables. The y-intercept. What does y-intercept mean?
Where it crosses the y-axis.
Where it crosses the y-axis. And is the y value when the x value of x is 0? In this case, when x is 0, the value of y is 0. For special cases like this, when the y-intercept equals 0, the equation becomes y equals mx plus b. After drawing the graph and obtaining the equation, check to see if the results make sense. The slope indicates the increased reaction distance for an increase in speed. It has units of meters per second, or seconds. And it is a time. It is the reaction time. This person's reaction time is 0.74. In grade 10 science, did you do the little activity where you drop the meter stick and you try and catch it?
No.
With your fingers? No? We might have time at the end of this period. It's sort of a measure of what your reaction time is, right? It's how long it takes before your foot gets to the brake pedal, right? Thus, the slope is a property of the system that the graph describes. The slope has some meaning. It's not just a number. In math, it's just usually a plain old number. No one cares what it means. In science class, we care what it means. In this case, it is the reaction time. The value of the value of y does not always increase with increasing x. If y gets smaller as x gets larger, then delta y over delta x is less than 0, and the slope is negative. Negative slope. Delta means what? Good question. The Greek letter D.
It looks like a triangle.
It looks like a triangle. It's a capital D, actually. Anybody know what delta means? No, you guys don't know? Okay. Delta simply means change. Delta means change. Here's a question for you. I've always wanted to know, being the nerd that I am, I've always wanted to know what kids in Greek high schools use for all the Greek letters that we use in math.
They probably use their own letters.
But then it wouldn't look different, right?
It wouldn't be difficult.
I've always wondered that.
Do they use our letters?
No, they use Greek letters. Oh, do they use ours for math? I don't know. I want to know. I was in Greece a few years ago, and I really wanted to ask some kid that looked like he was in high school, but my wife thought it would be weird and wouldn't let me. It would have been weird if some random guy came up to you and asked you that question. What letters do you use in math class? Yeah, it would have been weird. But I still want to know, Nate.
We use H.
Okay, so one of the things you had to do today was to recognize a linear relationship. It's pretty easy. It's when the graph is a straight line. What about quadratic? How many people know what a quadratic is from math class?
Oh, I hate this.
You hate this stuff?
I hate it.
Oh boy.
It'll be rough, isn't it? The rocky road from here on out.
Could be. Lucas, how do you know that an equation is a quadratic in math? How can you recognize?
It was out of my head, right?
No. Well, it's got an x, but it's x what? Quadratic. Someone said
Yeah,
it.
there you go.
X squared, right? X squared, and the graph is curved. You deleted, sent all to the recycling bin, right? Okay. So, the graph, figure 4, braking distance versus speed is not a straight line, but rather looks like a parabola. What is a parabola?
You told us yesterday.
No, I didn't tell you yesterday. It's that curve graph.
Oh no, it was Sheldon.
Oh, wait,
Sheldon said word parabola yesterday?
You were Sheldon. I heard it yesterday.
Me or Sheldon? Thank you. This indicates that the braking distance varies as the square of the original speed. In other words, twice as fast, 4 times as far. That's what a parabola will do. In other words, if you double your speed, the braking distance increases 4 times. The graph slope changes, so it cannot be calculated. You can, however, calculate the slope of the curve at any instant by drawing a tangent line. More on that in the next unit. Okay, shake your head, wakey wakey. Important question here. If it takes a person 40 meters to stop after driving at 50 kilometers an hour, how far will it take to stop if driving 100?
And what was the number?
Like more than 80.
50 kilometers per hour means you take 40 meters to stop. So 100 kilometers per hour means how far to stop? 60?
160.
160. You multiply by 4.
Double the other number equals
2 times the speed, 4 times the distance. Why is that? Because it's 2 squared. What's 2 squared? 4. If you're traveling 3 times faster, Mitch, then it's going to be how much farther? Squared.
A lot.
3 times faster? A lot is not an accurate enough number for me. 9. 3 squared is 9. 4 times faster? 16 times farther. And so on. Okay? We'll revisit that again. Okay. An inverse relationship. Or sometimes they call it indirect. Some relationships are such that as one quantity increases, the other one decreases. If something gets bigger, the other thing goes down. Can you think of anything where one thing gets bigger and the other thing goes down? If you're pushing something, the bigger the object is, the slower you go, maybe, something like that. Yeah, good. That's a good one. Yeah.
That's still going up because
If it's bigger, right, then it goes slower.
then the time you're gonna make more time.
Yeah, it's inverse.
The
This is the shape of the graph. This is an inverse relationship. It's curved down like that. Okay. Now time for you to do a little bit of thinking. You probably want someone to work with. There are 4 questions here. They get progressively harder as you go down. I'm going to give you 10 minutes. Well, the first 2 are like 30 seconds. I'm giving you 10 minutes. Okay, I think we've answered number 1, right? I guess I did that with the recording off. The answer was that the graph would look like this, and the y-intercept was 3.4, which means the whole thing is not possible. Wrong-o. In the earlier braking example, at what speed is the reaction distance 10? So you got to go way back to...
just under 15.
No, not that page. Where is it? Right here. Reaction distance 10. So you got to go across. So it's right around about 13 and a half, 14, something like that. Is that what you had? Around 14? Something like that? Okay. That's just a check. Can you read a graph? That's all that is. Okay. Now, here's where the questions get a bit harder. Number 3. A graph of reaction distance versus speed is made, and the slope is found to be 0.74 seconds. 0.74 seconds. That is the reaction time. Suppose another experiment is made and the slope is found to be steeper. What does it mean? Steeper means bigger number or smaller number? Bigger number. Bigger reaction time means slower. That's what it means. Slower reaction time. Maybe they're on their phone while driving. They've got a slower reaction time. Slower reaction time. Okay. Number 4 is one of my favorite questions because it makes you think. Okay? If you're not paying attention, it's time to start because this one's tough. Figure 6, right here, shows the relationship between the circumference and the diameter of a circle. What is the circumference of a circle? All the way around. Diameter is distance across. Would a different circle circumference create a different graph? How many people said yes? How many people said no? Okay, there's a few people whose hands didn't go up. You got to choose a side here.
Okay, so I don't know.
Yes, different circle, create a different graph. Come on.
I said yes.
Oh no, same graph.
Oh, we know.
The answer is no.
Oh, my God.
The answer is no. Here's how I'm going to prove it to you. How many circles have we got in that graph? Diameter. I've got a diameter of 1, and a diameter of 2, and a diameter of 3, and 4, and 5, and 1.5, and 2.5, and 3.5, and 4.5, and 1.25, and 1.26, and 1.27, and I could keep talking until the end of the period. I won't. How many circles are on here? An infinite number of circles that are simply, that's terrible handwriting, infinite number of circles that are simply less than 5 centimeters across. Right? Could we extend that line forever?
Yes.
Absolutely. Would it have the same slope forever?
Yes.
Yes, it would. The circumference of a circle is, do you guys know what that symbol means? No, infinity is this one. What does that fish thing you mean? That's alpha, I think. Yeah. It's proportional to the diameter. What's the formula for circumference and diameter? Pi times d, right? Right? What is the meaning of the slope?
The circumference diameter relationship.
It is the circumference diameter relationship. Absolutely. I should probably have B and C switched. Nate, pay real close attention here. What are the units of the slope? How do you find the units of the slope? You take the units for the y and you divide by the units for the x. Mitch, what are the units for the y? Centimeters. What are the units for the x? Uh-oh. When you take centimeters and divide by centimeters, they cancel and you got nothing. No units. Let me show you something. What's the quantity on the y? What am I measuring here on the y? Circumference. My slope is divided by the x, which is the diameter. I got c over d. Hey, we know a formula that has c and d in it. If I divide both sides by d here, c over d equals, and this is like a Penny Sheldon moment here, c over d equals, what, my friends, is the value of the slope of this line? 3.14. That is the meaning of that slope. It's the value pi. It's the constant that makes it work. Not an easy question. Generally, I don't get a lot of people getting that ahead of time. Give me a bit of a nod if you kind of follow along what I'm saying. No? I need to know. I need to know.
I'm honestly.
Okay? I'm not going to pull something like that out on a test on you. Okay? That's not testable. That's just sort of.
Like do it on the first worksheet then.
I'm checking to see what people know, Lucas. So it's okay. That helps me because then I know what I can do in the next few weeks, right? It's okay if you don't get that. That is not something that I would expect having been taught I would expect about half the class to sort of kind of get what I'm talking about after I'm finished. It will be what I expect. And it's no big deal if you're not in that half. No big deal. Okay, it's not that important. It's just, I'm just gauging where people are at. That's all. Okay? Okay, this you can do. There are 3 questions, and I'm going to have to run down and run off and pull up some graph paper for you right away. Question number 1 is easy. It's read the graph, write down some stuff. Question number 2, you're going to have to graph. Question number 3, you're going to have to graph. Oh, there's graph paper there. Do you have graph for number 2?
Yeah.
Oh, you got it right there. You don't need graph paper. Perfect. Okay, so I'm assigning questions 1, 2, and 3.
On the third,
I will, before the end of this period, I will give you the answers. I will go through number 1. I'll do that in about 7 minutes. And number 2, I will for sure do before the end of the period. 3, we'll have to evaluate whether we're done in time or not. Okay?
Okay.
Go.
no. Very slow.
What happens if it's in the center?
Take a guess.
Zero.
Like an educated guess.
Are we going for the square, triangle, or the
You
dot?
got to know.
What?
Read it. Remember what I said about 10 minutes ago? Read the
The
question.
graph shows the mass of 3 substances per volume between 0 and 60 cm. What is the mass of each?
Let's have a look at the answer for number 1. Graph shows the mass of 3 substances for volumes between 0 and 60. What is the mass of 30 centimeters of each substance? 30 cubic centimeters. 30 is right about there. So the answer should be about, what is that?
150.
55 or so?
Oh, it's 50. Oh, it's 60.
55, and then about 95, and then about 150. Right? Can you read a graph? That's what it is.
What are you doing with that?
If I did all 3,
I know.
what is the mass of each substance?
That first.
I started at the bottom. If you had 100 grams of each substance, what would their volumes be? So here, you have to go the other way. 100, and you're going to go there, and there, and there. And so your answers would be about 20, and about 33, 34.
Yeah, that's 54.
Okay, and pretty much right on 50, right? Those are pretty easy,
I'm good.
right? What are the units of the slope of the graph? What are the units here? Grams. What are the units here? Cubic centimeters. So the units of the slope are grams per cubic centimeter. Describe the meaning of the slopes of the lines in this graph. What do we measure in grams per cubic centimeter? It used to be in grade 10 science. It's not anymore. Anybody know? Grams per cubic centimeter. Maybe in chemistry. No, Nate.
The mass over volume, isn't that?
What is mass over volume? Anybody know?
I was thinking surface is 30.
It is density. Who said that? Density. D equals M over V. It is the density. Density equals mass over volume. Okay, we measure density in grams per cubic centimeter. What does density mean? It means like how heavy it is compared to how big it is, right? Things that are dense are heavy, but not so big. Okay, question number 2. So in question number 2, it's basically the same kind of thing, except now you have to actually plot the values. How many people have sort of started number 2?
I broke down the thing on.
Okay, I'll throw 7 minutes up, and then we'll check in 7 minutes where you're at. I'll go here. Okay. During an experiment, the student measured the mass of 10 cubic centimeters of ethanol. The student then measured the mass of 20 cubic centimeters and so on. Got this data. Okay. Plot the values given in the table and draw the curve that best fits all points. Okay, so we got 10 and 11. You guys, I'm sure, went 10, 20, 30, 40, 50. And up here, I'm sure you went 10, 20, 30, 40, 50. So I got 10 and 11. So right about there. I got 20 and 18.9. And I got 30 and 26.8. Oh, hang on. I shoot that one up, didn't I? 30, 26.8. Somewhere there. 40 and 34.7. And 50 and 42.7, so somewhere like that. Okay, when you draw the line of or the curve, you should recognize that it's a pretty straight line, like so. Describe the resulting curve. It's straight. Use the graph to write an equation relating the volume to the mass of the alcohol. Now here's where it gets hard. Okay? To come up with an equation. I kind of hoping you can do this for math class. You might need a little bit of a kickstart to get going here. Right? To write an equation, Nate, you need the slope. Slope is rise over run. Now, Kia, you and Carly, I should have reread the question before I helped you, right? You should probably do this because it doesn't go through 0, right? So rise over run, let's pick 2 points. Let's pick that point and that point. So my slope is going to be my y value of 42.7. Subtract this y value down here, which is 11. And this x value here is 50. And this x value here is 10. Well, the bottom is easy. 50 minus 10 is 40. The top is a little bit harder.
That's for C.
We're doing C.
31.
So I got 42.7. And I'm subtracting 11. Oh, I can do that in my head. What am I doing? 31.7 divided by 40, and my slope is 0.79. You need to calculate it.
One word is out of it. Can you believe that?
Can't believe it.
One word is
Try home harbor. 0.79. How do you get the y-intercept now? I don't know if you guys know this in math class or not. I don't know. We're going to try. Y equals mx plus b. I can plug in any y value I want. I'm going to plug in y is equal to 11. My m value is 0.79. What's the x value that goes with 11? 10 plus b, and I'm going to solve for b. So I got 0.79 times 10 is 7.9. So b is equal to 11 minus 7.9, or 3.1. My b value is 3.1. That's pretty close to what it is on the graph. Come on. The b value is 3.1. I took 10 times 0.79 and got 7.9, right? Okay. Find the units of the slope of the graph. And why isn't the y-intercept 0? Well, let's do what the y-intercept isn't 0. Why isn't the y-intercept equal to 0? Should it be?
No.
It doesn't have to be, but in this case, if I've got mass and volume here, right? I got volume and I got mass. If I got 0 volume, shouldn't I have 0 mass?
Yeah.
Yeah, probably, right? But when you measure something, you got to put it in like a glass container or something other, right? How much does the glass container weigh? 3.1 grams. That's what the little container weighs. That's why. Yeah, B stands for beaker? Not really. What are the units of the slope here? Mass is in grams, volume is in cubic centimeters, with grams per cubic centimeter. We're talking density here. I would like to see you have number 3 done for Monday.
I will.
That's my very best.
If I'm not,
Give it a whirl. It's one question. Do your best. At the very least, you can graph it, right?
if I don't get it, I will.